Hello guys, welcome to this section of SGW Selection like procedure by MME. So we know like in EPC, MME must kind of dynamically decide which serving gateway will be going to handle the subscriber data session. Okay, and this is not a random choice. It is kind of a systematic process based on some topology efficiency and network health. Now let's discuss about this and some with some call flow. Okay. Now suppose like we have the RRC connection setup, and after that RRC setup complete message will be there from UET node B. In that NAS attach request will be there. So and that request will be like forwarded to MME from the E node B, and it should contain like the NAS attach request with some TAI and ECGI. So TAI is the tracking area identity, and ECG is kind of cell group identity. So now, like here, MME kind of realize that it need to select some as gateway. Okay, so it is going to select that as gateway based on like use current TAI. So it will create one TAI FQDN, and like it will be putting like tag low bit and tag high bit with some EPCM and CMCC like this kind of FQDN it is going to create, and like it will begin going like it will be sending a DNS query to the DNS server, and like DNS server will be sending the DNS response, like it will be sending the list of S-gateway IP addresses and like priority for those S-gateway IP addresses, and also it could like add the weight as well. After that, like once the MME has the candidate list, it applies like these following logic to select a kind of selected gateway. Okay. So first of all, like MME prioritize as gateway that are kind of geographical or logically closest to the UE's current tracking area identity to minimize some backhaul latency. And if like there are some multiple S gateway kind of equally close, then the MME uses the DNS weights to distribute the subscriber evenly across the kind of all gateways. And there is one more option, like if the subscriber like requested APN is served by some P gateway, and that is kind of physically co-located with an S gateway, MME will like prefer that combined node to optimize kind of internal core signaling. And after that, like MME is going to send that creates a request over the GTP as GTP-V2C protocol, and here like it will be sending that NC ULI is the user location information, and it will combine the TAI and ECGI, then APN it will be sending, and it will be like creating some internal endpoint identifier for that particular MME, and it is providing FQDN for that, and also like it is going to provide some BLR context. And like there are some procedure like after that S gateway it will be sent into P gateway and all those things, and once it is done, then S gateway is going to send the create session response back to the MME, and here like it will be sending like course of whether it is successful or not, and then S gateway tunnel ID, so then like it can like the signaling flow will be completed, and also like it can send that as gateway FTID for S1U, like so that it can instruct G node B to follow that particular path for the user plane. Okay, now there could be like there could be some issues with that particular flow as well. Okay, so suppose we are having some S gateway selection failures. Okay, then we have to check the internal DNS, and like if the type FQDN is not provisioned or the DNS is unreachable, MME cannot find the gateway. So these kind of issues we need to take care of. Or suppose like there is kind of uneven SGW loading, or we need to then do the audit for the DNS weight parameters. Okay, so all these things we need to do for that procedure or for that selection. So from this slide we can see like S gateway selection is kind of a DNS driven process, and by manipulating DNS weights and kind of TAI mapping, we can dynamically manage core network load without ever touching the MME configuration. And that's all from this particular session. Thanks all. I will see you in next section. Thanks.